Okay, hello guys. Hello guys. I'll be making a video series on different topics of 9th standard science and technology standard 9. So the first topic in this video series is world of matter. It is actually a pretty simple topic, so we'll get through it pretty quickly. Now the first part in world of matter is matter and its properties. Now what is matter? Matter is anything that occupies space and has mass. Also another important definition in this part is what is mass. Mass is something that describes how much amount of matter is present in anything. Now if you go through your textbooks, you will find the definition of mass, however the definition of matter is not present there. So it is just a simple definition. Matter is anything that occupies space. Another important definition in this part is volume. Now what is volume? Volume is the amount of space that matter occupies. Okay, so these are pretty simple topics like mass, density and volume. Now we have a formula for density here, which is also pretty simple. We'll just take a look at it. Suppose this is D, that is density, which is equal to mass upon volume. Now mass can be given in any of these units, such as grams, or kgs. Grams, kgs, I hope you understand this. And volume is expressed in grams. Sorry, I am extremely sorry. Volume is expressed in centimeters cube or meters cube. Now these are just the units in which these quantities are described. Okay, mass is expressed in grams and kilograms, while volume is expressed in centimeter cube and meter cube. So from this you can easily derive the unit of density, that is grams per centimeter cube, or another unit is kg per meter cube. Now the most commonly used unit is grams per centimeter cube, and for your general knowledge, let me tell you that water has a density of 1 gram per centimeter cube and 1000 kgs. 1 gram per centimeter cube. Water has a density of 1 gram per centimeter cube. Now this is all about matter, mass, volume of any matter, and density. Now we have a problem here. Problem in what I mean is a question. So we have a wooden block of mass 12 grams. This is very important, the unit grams, and has dimensions 2 centimeters into 3 centimeters into 1 centimeter. Now basically we have to find out the density. Okay, so we just learned a formula. Just to learn that density is equal to mass upon volume. So we can simply put these values in this formula and get the value of density. But there is a problem here, that we know its mass but we don't know its volume. So first we have to find out the volume of the wooden block, which will be equal to the multiplication of all these quantities. You see, 2 centimeters into 3 centimeters into 1 centimeter, that gives us a volume of 6 centimeters cube. Okay, so we put those values in this formula and we get 12 upon 6, which is equal to 2. Now the unit of this value will be grams per centimeters cube. Okay, you can easily get this unit, like, see, mass is given in grams, so here it is grams, and the volume we just found out is in centimeters cube, so here it will be centimeters cube. So you can simply make out grams upon centimeter cube, grams upon centimeters cube. Okay, so 2 grams upon centimeter cube is the density of this wooden block. Now this is a pretty irrelevant question because wood will never have such low density. Okay, it is always larger than this. Water, as I told you, water has 1 gram per centimeter cube as its density, so wood will certainly have more than that because wood is a solid. Okay, we'll learn about how are particles packed in solids, liquids and gases further. So let's move ahead. That is states of matter. Now basically there are 3 states of matter which are widely accepted, that is solid, liquid and gaseous. That is solid, liquid and gaseous. Also another accepted state of matter is plasma. However, we won't be talking about that in this topic. So let's talk about solid state. Now consider this as a wooden block. Okay, this is just the outline of the wooden block. So since wood is solid, particles in it will be placed very close to each other, and there will be a definite arrangement of these things. Okay, so they are arranged very close to each other and in a pattern. Now consider that this is a container and a liquid is filled in it. So how are the particles in a liquid? Well, they are not very pretty close to each other, and also there is no definite arrangement. Okay, and gases is just same as any liquid, only the particles are very far away from each other. Actually they are not big, but they are just far. The size is the same, but they are very far from each other. Just a second, I will give you a clear idea. Okay. So this is a solid, this is a liquid, and this is a gas. Now solids, they have a definite shape, they occupy a definite volume, and since the particles are already very close to each other, solids are incompressible, they cannot be made further smaller. Okay, some solids are elastic, that is they can change their shape, and solids are also quite stronger than liquids and gases. Now liquids are slightly less denser than solids. So liquids have their particles arranged in any manner, they do not have a definite repeating pattern or any pattern of any kind. Also the particles are far away as compared to a solid, and liquids can be compressed further. For example, if you take water and apply a very high pressure on it, then it will just get converted into ice without any need of cooling. Okay, so if you just apply enough pressure on liquid, it will convert into ice, that is, it will convert from liquid to solid. Now the case about gases is that the particles are very far away from each other, and the particles move in a random motion. These particles move in a random motion. Now basically the reason why this happens is the force of attraction between particles of a solid is very strong. It is a force of attraction which is very strong. In case of liquids, yes, they have a force of attraction between two particles. However, as there is a force of attraction, there is also a force of repulsion between these two particles. In solids, there is only a force of attraction which keeps them binded together. However, in case of liquids, they have force of attraction as well as a force of repulsion, because of which the particles cannot get very close to each other. In gases, there is a very little force of attraction. However, there is a very strong force of repulsion which pushes these particles very far away from each other. Now there can be various reasons for this. For example, gaseous particles are very high energy and therefore they cannot get very close to each other. Solid state has the least energy in their particles, that is why they can sit very close to each other. Now gases are highly compressible. Okay, now if you compress steam, you will get water. You further compress water, you will get solid ice. So that is basically gases are highly compressible, and gases and liquids they take up the shape of the container in which these gases and liquids are placed. Gases as well as liquids can flow from one thing to other, while solids cannot flow. Now another important part in this is change of state. Now consider, we'll take an example of ice, water and steam. Now this is ice. This is ice. Then we have another container which contains water, and then we have another container which contains steam. Okay, now the size of the containers is different, but please understand. Now the temperature of ice is 0 degree Celsius. Temperature of water ranges from 0 to 100, while the temperature of steam ranges from 100 and above. Okay, so the temperature of ice is 0, temperature of water is from 0 to 100, and steam has a temperature greater than 100 degrees Celsius. Now whenever, since I told you that particles in any solid state have least energy, those in liquid state have a little higher energy, and gaseous particles have very high energy. So what happens is, when you heat ice, the heat energy goes into these particles and they acquire higher energies. So when you heat ice, it gets converted into liquid because the particles have acquired greater energy due to the heat that you provided. Then if you further heat water, these particles will acquire further more heat energy, and these particles then get converted, or they simply start going far and far away from each other because they have very high energies which they get from the heat that is supplied to the container. So then they get converted into gaseous particles. Okay, so now if you try to if you take the temperature of this gas, it will be greater than 100 degrees Celsius. If you compress it back to liquid, that is water, and if you check the temperature will be in the range of 0 to 100. And again, if you compress liquid water and form ice, then the temperature would be 0 degrees Celsius and less than that. Okay, this ice can exist below 0, it does exist below 0 degrees Celsius. Now what happens is, when you compress steam, what happens is these particles lose energy. And because of which the temperature goes down. Again, when you compress liquid, again these particles lose energy. And they get very close to each other since they have very less energy, and they form ice. However, ice at normally room temperature is considered to be 25 degrees Celsius. So if you keep ice in any room, then what happens is, the temperature of the surrounding is greater than that of the ice. So what does ice do is, it absorbs heat from the surroundings. These particles get higher energy, they get converted into water. Now water does not simultaneously get converted into steam, at room temperature. Some part of water does get, because it again absorbs heat energy from the surroundings and gets converted into steam So that's all about the states of matter, change of state of matter, and the corresponding change in temperature. Thank you, and please await my next video in this series.